My goal is to give you a little bit of a view of what the security posture is for organizations today, what security people think about, and what are the things that we need to do as DevOps people, as developers, as people that run the platforms to make sure that security people are pretty happy. So the one thing I'm going to ask to do is to put your security hat on. So think of yourself as a security person in a company. You've been doing more or less the same thing for, I don't know, 20, 30 years. You've been taking care of maybe some older computing systems. You've been taking care of things like your computing environments, your network environments, and you have a pretty good experience in what you do. And now, maybe like a couple of years ago, a year and a half ago, somebody told you about containers, and you were scratching your head and thinking, well, why do I need to deal with that? And they told you, well, the organization is going towards that. Somebody's building applications. Docker and containers in general are pretty awesome. And you were like thinking, OK, so now we're at a point where containers are not the normal, right? It's not the new normal anymore. We've matured. And because of the scale, the simplicity, portability, and speed, security people are really starting to kind of get used to that idea. And you don't get the deer in the headlights look that you would probably 1.5 to 2 years ago. Now, that doesn't mean that security people are happy by any standard. That means that they're just kind of trying to wrap their hands around the problem. And what happens is that in the stack, and Sarah had a probably better technical representation of that, but conceptually, we work in several layers in IT to provide security controls and make sure that our applications are secure. So the application payload, right, the code that runs in the application, the thing that actually other things usually connect to, are the ones that people should be concerned with. And containers are really still applications. They are really for the outside view, a web server is a web server. It doesn't really matter if it runs in a container, or if it runs in a VM, or it runs in a bare metal, or it runs as a cloud service. To the outside world, it looks the same, and therefore it's susceptible to all the other things, including the attacks on it, including anything from hostile takeover, privilege escalation, data exploitation, and so on and so on. So again, you're the security person that's for the last 20, 30 years has been protecting applications in different kinds of stacks, right? Maybe the container orchestration wasn't there. Maybe it was directly on the host. Maybe cloud wasn't there. But it's really the same way to protect applications. So what are the tools? What are the things that security people do to protect applications? Now, I'm a security person, and I would reduce the entire practice of security, the millions of people that work on it, and the enormous amount of money that we're being paid, to basically 3 concepts. Firewall, antivirus, and policies, or basically things on the network, things on the host, and things that you tell other people to do. So if you think about firewall, it's firewall, web application firewall, network intrusion detection systems, security zones in Amazon, security groups, whatever. And you have basically anything that would put an enforcement point on the network. The other thing is anything that would put an enforcement point on the host. So that goes for antivirus, host intrusion detection system, host intrusion prevention system, syscall monitoring, everything that you do on a computing assets, regardless of where it is in the stack. And the rest of it is policies, identity and access, authorization, authentication, telling people not to do stuff which they ignore anyway, telling people not to click on links on emails. That's why you need the antivirus. And all the stuff that deals with just the practice of dealing with people. People are still the major problem for security. So we have a very changing security environments. We have the places where the networks are. And the sweet spot for all of that is still the host, the network, the data center. So what do security people know how to protect? Security people know how to protect infrastructure. Right? There's a little bit on the packaging and development side, so things like your Veracode and checkmarks of the world to scan your source code. There's kind of vulnerability management that's related to antivirus. There is payload, application controls, containers, container firewalls, things that we can do all the way from Istio to things that are more security-oriented for the container. But basically, it's the same thing, the same story over and over and over again. And that's great, because it fits the one and only deployment model that is always constant in the world, and that is your on-premise deployment. So on-premise deployment has all these things. They all live usually within your domain. You have access to them. And those things can be secured in one of these 3 methods, usually in the course of the life cycle of that. So came cloud, quite a few years ago, and VMs, and we sort of abstracted the data center. So security people had a little bit of a problem with that. How do we know the assets? How can we, make sure that people don't go into Amazon's data center and steal our VMs? And of course, that's not possible because Amazon's data centers are built in a desert somewhere and nobody can access them anyway. But that was one of the issues. And you can see that we start to lose some of that control. That doesn't mean that we lose the control completely, but we are starting to lose some of that control. And then came managed container services, so your Azure Container Services, Amazon and Google. And we're now, you may not have completely abstracted the host, but you have limited influence on the host, right? Because if it's certified for that container service, you can't really put your own antivirus on that host. It's provided for you by the cloud provider. So we're losing a little bit more measure of control. Then came containers as a service. So your infrastructures that like Fargate, like ACI, where you are throwing a container out there and you really don't care or really should know what the orchestration of that container is. And of course, you already have lost the host, the network, the data center. But at least you package it, right? At least you have the image, and that image, as Sarah said, and others, that is very important. The security of the image, the things that go into the image, are really the seed of all the security that will go into a container. But then we go into a world where even that's not going to happen, right? You just throw code out there. You throw code, somebody then puts it in what is presumably a container, and that container just runs in a environment that you totally don't control, and eventually you just get an application that's running kind of out of the thin air. So those are the kind of things that literally will drive security people crazy, because the sweet spot is just not there. We've abstracted the one thing that security people know how to do, and that is why they are really, really cranky these days. So, and by the way, this is not far-fetched. By the way, this model of serverless functions, to a security person, Pivotal Cloud Foundry is a serverless function. Because you throw code out there, you throw a droplet out there, it gets amalgamated with the rest of the baseline packs and runs somewhere. OpenShift S2I is also, to a security person, more or less a serverless platform. You throw code out there, it gets bundled with the base container, and then gets shipped out there. Things like what Microsoft is doing with Draft, the same thing. Those are still, for a security person, lack of control. So it doesn't really have to be outside of your environment. It just has to be outside of the sphere of influence. So let's put our DevOps hats back on and see, well, how do we help our poor security people? Our job is to make sure that what we do in the security space makes sense for the security of the organization. Security people are not evil. They're not just there to say no. They have their own pressures, auditing, compliance, GDPR, and other things that are mandated in order for that to happen. So we know about shift left, which is to start to put security controls into our packaging and deployment, and that is everything that has to do with making sure that your images have a good risk tolerance and that your code is secure to the extent possible. I would argue that shift up is the ability to then insert security controls, or at least program your applications in such a way that if it is a standalone container, if we don't have the crutch of a host or the network or places to put our security controls, it will still run securely. So how do we actually do that? So shift left starts with just coding. So write code with security in mind. I know it's very, very easy to say, but as you start to think about what your code is, we have made some assumptions, right? Developers really never cared about like the version of the operating system that's going to carry their code. But what if that operating system really isn't managed by anybody? Because you count on security to actually manage that underlying operating system. So write as if you are writing it to run in a public cloud, the same way that you don't want to post anything on social media or Facebook that you don't want anybody to read. Don't put code out there that you don't want anybody to explode. Use the leanest, most efficient base operating system. A few people mentioned building from scratch. If you can do it, that's great. If you cannot do it, make sure that your operating system is as lean as possible. Don't store any keys. Don't store any sensitive configuration in the image. There are ways to kind of put them there. Think about what user your application runs under. Do not put anything in the cloud that is wanting to run as root by default. And then choose the open source components that are completely free of vulnerabilities. And that is, of course, impossible. So how do we deal with making sure that vulnerabilities are not just something that we want to avoid, but something that we need to manage? And we need to manage them because we need to understand how they're being exploited and what are the chances that somebody's going to exploit it in your particular application, in your particular way of running that software. So on the shift upside, we need to start to look at security, and that's kind of on the collaboration between security and DevOps. We need to start to look at security as something that will be closer to the assets. We really can't have security detached from the application. So how do we reduce the attack surface? Right? Allow only what the application needs. So even if you don't program from scratch, don't put packages that can be used in an image, and make sure that there are ways to control what a container can actually run. Prevent adding any processes to a running container. So don't open those interfaces that allow administrative management into that container. Design the applications in a way that runs in one service with one user for one purpose. Simplify your world and just play a little bit of a what-if game, right? If you compromise that container, if you can exec into a container as root, what can you do? How much damage can you do? How much damage can you do around it? Because you probably are not going to have a lot of those supporting structures around you if you go to a serverless environment. And what that will do is it makes security portable, regardless of environment. You don't want to reprogram your images and re-architect your application just because you need a burst of capacity in Fargate, or you need a burst of capacity as a serverless function. So think of security as built in, and let's make sure that that what we do is something that can be portable even to those environments where we don't have the support structure of all the entire infrastructure stack. So a few things that we want to do. I mean, I like this graphic because it kind of shows you that doing this is kind of walking a tightrope without a net between the development and when the application is running. So there needs to be some things that the industry will need to do. And Aqua is doing some steps in that direction. Other players are doing some steps in that direction. We haven't got this completely solved, but we are working towards a world where rogue deployments, monitor inventory, image trust, very important to understand where images are coming from, enforcing the immutability in containers so that if you run them, nobody will be able to add any malicious code into them, making sure that the operating system of the container, if it's needed for the application, is not going to be opened for administrators. We can't put anything sensitive in the container, so we got to ship it in real time. So how do we do secret distribution? How do we do service connectivity? How do we apply service mesh to a container that might run as a one-off? So can we just run a container with Istio, for instance, on something like Fargate? How does that work together? The industry will have to kind of come to terms to that. And then built in those preventive security controls so that you are protected against the zero-day attacks just because you've done everything else right. So that kind of environment is going to allow us to connect the dots. So if you don't leave the security to the very end, if it's bundled in, you really can't count on the things that you would count on the host, because you might not have access to the host. Of course, there are hosts somewhere in the stack, but you don't own them. You really don't know what the security of those things are. And your deployed application is going to be the first and last line of defense. You're going to throw something out there. It's going to have to fend for itself. So understand what you are putting into a container. Understand that your community footprints is going to increase. There's going to be more and more components that are going to be open sourced into your applications. And then understanding what your application does, what is the intended use of the application, is going to be extremely important to protecting it, because we need to differentiate between operations that are allowed and not allowed. So that is kind of the end of part one of the talk. I want to kind of throw out there a tool that can help you start that process, especially on the image side, and that is the Aqua microscanner. The Aqua microscanner is free. Free as in beer, so it's not open source software, but it is, you don't have to pay for it. You can run it as part of a build. It uses the Aqua security commercial grade vulnerability intelligence. That means that you get access to everything that Aqua does with our customers on an enterprise level, and it will scan for operating system and common open source software. This is a sample of the output. So it's a JSON type output. It gives you the impact statement of the vulnerability, so you can get an understanding of really why that vulnerability is there. NVD data, so that's where the repository of kind of the official vulnerabilities are. The maintainer data and the score, and then some advice on how to fix it. just a word about vulnerabilities. Don't get taken aback by the fact that you have a lot of vulnerabilities in your images. Vulnerabilities can't be avoided, and it's a matter of understanding what the impact is. It's OK to have even a high 10 vulnerability in your image if you have a good plan on how to mitigate it elsewhere. So understanding what that is and going with open eyes, even talking to your security people and telling them, look, I need this piece of code. It does have high vulnerability. I have a plan how to mitigate it, is going to go a long way towards making your code more secure and eventually the applications more secure. So please use it. This is the GitHub repository for the microscanner. You can register for a free token. You can download and run the microscanner in the Docker file. And this is basically how you use it. So for the powers of time, do we have time for a demo? Yes. All right. Cool. So let's do that. So this is just my Docker environment. It's going to be the quickest demo ever. I have a few files here. I have a Docker file. So my Docker file is basically this image that I'm building from is open to everybody. It's our kind of test bed for bad stuff. It's built on a very old version of CentOS, and it has a lot of vulnerabilities in it. What you need to do is get the microscanner, which is available from the HTTP download. You need to make it executable. It runs with a token. When you register, you get your free token so that we can, it's under fair use. You get 100 scans a month. And if it runs OK, at the end of the build, we're going to echo no vulnerabilities, and then your image is going to be built. If I go into my run build, this is basically what's going to happen. So I'm going to run the build and build an image. And the microscanner is going to run. What it's going to do is it's going to enumerate all the layers that came on top of it. It's going to reach to Aqua's cloud service. And it's going to just output a big JSON of all the components and all the vulnerabilities that were found in that image. And eventually, it's going to give you a summary of how many total vulnerabilities were there, how many high, how many medium. And if there are high vulnerabilities, unless you give it a specific flag, it's going to exit with error 4 and stop your build, because we really don't want high vulnerabilities. If it exits with error 1, that means that there is something wrong with the process. So 4 is the one that you want for vulnerabilities. So let's kind of take a look at the output. And I did that before and kind of output it to a file. Here's my favorite thing about vulnerabilities, and you're going to see that again and again if you look at the results there. Let's find, I think it's the second one. Yeah, so this is my favorite vulnerability around the result that you get from NVD. So it's a vulnerability labeled 2014-6278, and it has a bash problem that can potentially do some trouble. And the NVD says it's 10, so the NVD score is really, really high. And it's really, really dangerous, and it has all these attack vectors. It can come from the network, and it's easy to exploit, and so on. And we give you the URL of what that vulnerability is. So if you get that from any other vulnerability scanner, that's going to be a problem. Security people are really going to give you some trouble around that. But what we did see when we correlated that with the Red Hat advisory is we saw that, well, Red Hat says, not so fast, right? We really don't see that as a security problem. It's a bug. There's probably a bug, but we've mitigated elsewhere. We have some things around it. And it's a negligible vulnerability. So we got to understand that not everything that comes out of a vulnerability scanner is something that we just need to take as granted and just get rid of that component. There's a lot of nuance in there. There's a lot of backporting. There's a lot of components. We have a full presentation, actually, about the complexities of vulnerability management. You really got to know what you're doing. But hopefully, this tool, which you can use on your images, on other people's images, you can build from any public image and then add microscanner and run it, and it will do the vulnerability analysis. Hopefully, it will put some order in it, and it will allow you to have some meaningful discussions with your security people. So I'm going to wrap up.